Yeah, it's recording now.
Rachel, so I'll give you the floor.
What?
You can introduce yourself
Yeah.
and yeah.
Okay. So hello, everyone. My name is Rachael Phillips. I am a senior consultant for Microsoft. I mostly work in the MLOps area at this point in my career. I've done lots of data engineering, data science, and now I'm in the MLOps space, which was a pretty new and unfamiliar place, mainly the operations side of things. So this presentation will be a pretty like general. It's an overview for MLOps with Azure Machine Learning. What I'd like to do is, at a later date, I'd like to do another one with an actual demo. I don't have one today. But anyway, so that's what we're going to talk about today. So if you have any questions or comments or anything in general, don't hesitate to stop me and ask or comment. Okay, cool. So, all right. So the table of contents for this presentation we'll talk about will be the machine learning development flow, challenges of ML model management, DevOps and what it provides, and then bringing machine learning and DevOps together, which is MLOps. And then, of course, I have some resources you can look at the end. So, so the machine learning development flow. So we all kind of know, the data science process. As we start, we have to first understand the business and the business use case for the machine learning what's the project that we're about to do. Then, from there, we kind of figure out what's the problem here. How can we bring value? So I'm going to speak from a consultant's perspective because I'm always going to say clients because I am always working with clients. So, so yeah, we understand what are the pain points for the business and their, what is it they need help with. The next piece is, data acquisition and understanding. So, we need to, where does the data come from? Most of the time it's several places, on-prem, cloud, flat files, all of that stuff. Then we have things like the pipeline, and this is more of the, the ETL process. How are we getting the data from where it lives to where we want it to be so that we can actually play around with it and, do some data discovery and then of course modeling and all that good stuff. Then we have, environment, so on-prem versus cloud versus data lake versus, big data, etc. And then wrangling, exploration, and cleaning. So structured versus unstructured data, data validation, cleanup, visualization, and so on and so forth. So then that brings us over to modeling. So once we actually are able to get the data and understand it better, and of course, in that process, you're always asking like the business, what is this? How does this work with this? And of course, they're going to understand their business much better, unless it's your business. If you're doing this for your own business, you probably understand the data pretty well, but most of the time you have to reach out to somebody to understand what things are, especially in real life, because the data ends up being like so much more complicated than you would ever think, like especially with like if you go and do any tutorial in data science, like the data is always like so clean and nice, and then you get in the real world and you're like, what is this? I don't even know what to do with this. So so there's a lot of data cleaning and understanding that goes into this piece of the process. And so that business understanding, it kind of goes back and forth. Like you're acquiring data and you're still trying to understand what the heck is going on with your data, what does it mean, and all that. So then we go to the modeling piece, which adds in, we do feature engineering, binning, text, image, feature selection, feature extraction. Then once we have that actual like set of features, and of course we have to look at the relationships of the features too, which I'm sure everyone here knows. But if not, you know that you have to look at the relationships depending especially on the business use case. So what kind of algorithms are going to help you decide what you want to do. So so that kind of changes. Sometimes you have to make assumptions with the data, and so you have to test the relationships to make sure that your assumptions are correct, or at least as correct as far as you know. Then you can choose, okay, this model training, what algorithms, can it be an ensemble, which means multiple algorithms combined together, parameter tuning, retraining, model management. And then of course we have model evaluation. We need to cross-validate it. We need to do model reporting and A/B testing. And A/B testing is like, if I have one model for A, one model for B, how are they doing in kind of more the real world? And then, I get to choose which one is actually performing better for my business use case, and then I choose that one. That's kind of roughly how A/B testing works if you weren't aware before. And then of course we have the piece of deployment. So scoring, performance, monitoring, all of that goes into the deployment process, which then, you have the customer acceptance, and then this is an end. But as you can see, it's always a continuous improvement and continuous integration and development. So any questions on that? I think we're all okay. I'll keep moving. So this is kind of just breaking that down. I won't go into this too much, but building the business understanding. We begin with an exploration of a problem. What's the problem they have? What's the analytical question that addresses the problem? And then of course, understanding their data and that's required to address the problem, and what data do they have at their disposal. That's a big thing I've found with clients, is having, sometimes you're like, oh, this piece of information would be super useful and probably be really great for a model for this problem, but they don't actually have the data, or the data is not good enough to even use. So that's another thing that kind of comes up a lot. And then of course, defining the consumption experience. So how will people or systems use this? Use the conclusions? What kind of value does it bring to them? And that's the biggest question, is what value is this going to bring to you guys? How are you going to save money? Are you going to gain money? Are you going to, is it going to improve your processes and save your employees time? That's kind of, what they mean by the consumption experience. So, we ask these sharp questions for the process, which is how much or how many, and that's of course a regression question. What category? And of course, this is again based on the business use case, but you can have categories, regressions, you can have clustering, which is what group does this guy belong into, or these customers. Is this a strange experience or something that's not normal, anomaly detection, and of course, which option should be taken, which can also be like a recommendation. So from there, we have the data prep and modeling, which then is acquiring the data, exploring and transforming that data, and begin the model experience. And then also, experimenting with the variables or the features. And you might end up going and revisiting that data to understand or get an even deeper understanding of that business problem, or even just the data itself. And data prep tasks can be repeated many times, as probably everyone here knows. And of course, rigorous model evaluation. So we need to thoroughly go through a model and make sure that it's performing. And also double checking our assumptions is also good. And then we have deploying and monitoring the performance. So model deployment or operational, oh my gosh, I can't say it. Operationalization, sorry. I was like, can't even say that word. Model performance, we want to be able to say, where are we deploying this to? Are we making it dashboards? Is it a systems? Is it a web application? Where is this going to get ingested and trained as well? So monitor performance is like continuously monitoring the model performance, refining the model based on field feedback. And that's of course like as your model is being put into the real world, how is it performing? That's when the field feedback is going to come in, because we train a model, and then once we deploy it, it might have a different reaction in the real world. And so we might have to go, most of the time you end up retraining the model on new data, and things change over time. So that's part of the monitor performance. And then we of course want to move past experimentation into that production phase, integrating it with dashboards, apps, whatever, wherever it needs to live. And of course, that depends on your users and who's actually consuming this information. And then monitor performance accuracy and revisiting the modeling stage to refine the model as needed. I'll take a pause here. Are there any questions or comments so far?
Good.
Cool. Okay, so this is a big one. Model monitoring, and this is where the DevOps comes in a lot too, which is real testing, right? So when we real testing of a model happens in a live environment. There are three main reasons why a model may show unexpected behavior once it's deployed and actually in production. So the first one is model bias. And this is something that maybe when you're training the model at first, you obviously don't see that, because you wouldn't put a model into deployment if you saw model bias. But eventually, that might be the case. New data might make it, the original model that you had, it might create a bias that you didn't expect with the model that you currently have. That's why we do retraining. So, the model, essentially, we know model bias is the model was wrongly trained because the model's prediction, differs from the target value compared to the training data. So obviously we want the optimal situation here. There's underfit, overfit, so that's why we retrain models, and that's part of the operations side of MLOps. Then data drift. So this is when the features created to train the model have statistically changed over time. So an example of that might be the company has gained a new and younger customer base with different characteristics. So they might have less experience, low budget, etc. That model didn't see that before. So now that feature that you had has changed over time. And so then that would be another reason to, reevaluate your model. And the last one is concept drift. And these are just like the main three. So the features are the same, but the value of the target variable has changed. So examples of that, maybe the company launches a new product to the same customer base, and they might not respond to it the same way as they did the other products. And something like change in interest rates, salaries, which can cause churn of clients or attraction of some kind. So with all of that, we want our models to be successful. So the accessible ingredients for the data science project is know your problem, definitely know your data. That's probably, like, I would put a big giant star next to that one. It's very important. Building relevant models and integrating them with your business or the business that you're helping, depending on if you're a consultant or not. So with that, we have like a whole team that builds a data science project. So we have the data architect. The architect builds the bigger picture, the architecture, the whole data platform. They design the data governance strategy, and they ensure data security and privacy. The data scientist does all of the fun stuff. They understand and help refine and shape the analytical questions to be answered. They craft approaches for new analytical technical foundations, statistical testing, machine learning, data lakes, and all of that. They conduct the analytical modeling, testing, and evaluation and interpretation. And they, of course, assist in monitoring and adjusting for model performance over time. So then we have, that's when, okay, that's the person who's playing around with the data, figuring out what the model should be, the best performing model, and all of that. Then we have the data engineer, who's the person who acquires all the data for us, transforms it and stages it / stores it in, wherever we're pulling that data from. And they orchestrate data acquisition and flow through to organizational data stores. They create and schedule and provision foundational orchestration services. So they're the ones figuring out how to get you your data so that you can play around with it and use it to improve their business. And then lastly, we have the machine learning engineer, which is the implementer of the MLOps pipeline. They deploy machine learning solutions into production, and they optimize solutions for performance and scalability. And of course, being all 4 people doesn't sound, it sounds like a challenge. So, so the main challenges of ML model management. So traditional data science delivery, I have a model for you. How do I deploy, manage, or monitor that? Because that's where the operation part. And so we have the data scientists, and then we have the operations team, and how do we collaborate together? Especially with things like data drift, model decay, stale models, and concept drift. So the big challenges of that are reproducibility and auditability. Sorry, I didn't say that very well. What data the model was trained on, which version of source code was run, what kind of hyperparameters the model used, what was the performance metric, and then of course we have validation and packaging. So how do we validate the quality of code? How do we make sure the best model is selected? And then lastly, we have automation and observability. How to make sure that the right model is being deployed, and how to monitor the live performance of the model, and when do we retrain the model? All right, so now we're going to talk about DevOps, Azure DevOps, and what it does. So MLOps business values are continuous delivery. We want to build an automation to enable continuous delivery and continuous integration pipelines. And we want to reduce downtime. So ensure ML models have required governance and operational discipline related to data quality, security, and compliance and access. And then predictable performance. We want to enable monitoring so that if something goes wrong, someone gets notified of that and they can go and fix it. Then we have other things like performance data collection across the build and inference pipeline, enabling a predictable ML operating environment. So those are the 3 things. So DevOps is a union of people, process, and products. So continuous delivery includes a lot of things. We deploy the model, and that could be a first time, or it could be the 50th time. We operate, monitor and learn, plan and track, develop, build and test. And that's a continuous delivery process. So people collaborate early and often, cross-disciplinary teams, share common goals and metrics, and shared responsibility. Process includes agile principles, streamlined feedback, delivering value faster, and products enhance productivity, improve collaboration, facilitate experimentation and measurement, and automate processes. So DevOps practices are version controlling, and that means, if I put some code in, and it doesn't work, I want to be able to go back to the, previous version so that I can, understand, okay, what did I change and why is it not working? So that's kind of the idea of version control. And then of course, especially if you've got a deployment, you've got that deployment, and, if your deployment breaks or something doesn't work, you want to be able to step back and be like, all right, let me go back and rerun the old version so that I can, re-collaborate here. Infrastructure as code, which is essentially being able to structure the code in a well-organized manner. Continuous integration. So we want to be able to know when things are succeeding and when they're not. So that's, green and red, success and failure. And then we have microservices, monolithic and layered, or just a service that's, under something else that, needs to be paid attention to, I guess, if that made sense. Maybe that didn't make sense. And then we have continuous delivery. We want to be able to, and this comes with, I don't know who on here knows about Agile, but on a regular basis, I've always been with customers, and we usually do an Agile process. And so that means essentially you're going to have what they call sprints, which are short-term goals for a longer game. So in sprint 1, you might want to do these tasks. So with DevOps, you actually have like a task board and people who are assigned things so that all the work can be done and the right people can take over the right jobs or things that they need to do. And then the last thing is monitoring and logging. So there's a way for you to focus on what's working, what's not working, and monitor all of those processes.
Rachel?
Yeah.
Can you please return to the previous slide for a second?
Sure.
I just want to say about infrastructure as code. Just to clarify, so what it is that you're managing your computers, how you provision your computers. You write code or maybe YAML files or something which defines your computer infrastructure. And then when you run it, these computers are provisioned. So I just want to explain it in like my words.
Okay.
Maybe it's a little bit helpful.
Oh yeah, thank you. I appreciate that. Was that it?
Yeah, that's it.
Okay, awesome. Thank you. Okay, so bringing the two together to form MLOps. Sorry, one second. All right, so obviously MLOps is a combination of machine learning, and DevOps. So we have these three pieces. We have the experimentation, which we talked about: business understanding, data acquisition, exploratory data analysis, and modeling. Then we have developing, which is code refactoring, versioning, testing, and validation. And we have operations, or operating, which is model deployment, the CI/CD. So CI is continuous integration, CD is the continuous deployment pipeline, and then monitoring and triggering. So an MLOps workflow, roughly we have preparing the data, which happens in, it can happen in, wherever the data is stored. So like it could be data lake, a SQL database, an Azure SQL database, and we can use things like Databricks to actually like, what's the word I'm looking for? Manipulate and edit the data. You can also do that in other places as well. You don't have to do it in Databricks. You can do it in, you can actually do it in Azure machine learning as well. But sometimes it's good to use Databricks because it does have that's underlying Spark, which makes it run faster. So it just depends on the use case. But essentially, then you have the part where you actually experiment and you build. So you build the model, you train and test the model, and then you register that and manage the model. And then you deploy. So build the image and you deploy, service, monitor, model. So that all is included in orchestration. So that's like the whole, enchilada kind of thing. And so, when we do that with the with the DevOps, we have boards, which are where the tasks and all of the stories, they're also called stories, which have tasks that and sprints and all those things, which is the agile process. There's definitely more than just the agile process in DevOps. I believe the waterfall is also used. I just know agile, so if you have any waterfall is not important to this conversation. I'm kind of rambling at this point, so I'll move on. And then we have repositories where all the code lives. So that's where we check in. That's where we can keep everything in line, where we could say like, oh, okay, here's all the commits that I did, which is I edited the code and then I committed the change. And so things like that. So that's the repository is there. DevOps also has the pipelines and the test plans. So that's where that train and test model comes from or lives. And then when we register and manage the model, we use artifacts and pipelines in DevOps to do that. And then the model monitoring is the Azure Machine Learning Service. So that's where the model lives, and usually where you pull in the data as well. Like the data doesn't live in Azure Machine Learning, but it has to call the data from somewhere else inside the Azure ML so that you can use it in your model in the Azure Machine Learning Service. And then lastly, we have application insights, which every time you create an Azure ML service, you have an application insights that it's attached to, which the application insights is where you can go and monitor things, and you can go and check. It's like it's an extra piece that you have to actually enable, which I found out recently. I thought it was automatically enabled, but it is not. When you create the Azure Machine Learning service, the application insights is automatically created, but the fact that you can use it, you have to add on because it costs more money. So people don't always use it. Okay, so continuous integration MLOps. We have tests, and then that builds so the training pipeline includes testing, launch the training, evaluating the models, and registering the models. And then what they do is it creates a scoring Docker image, or it deploys the model, which you can do with the Azure cloud, the CLI, the Azure cloud integration. I think I'm saying the wrong words.
Endpoint?
The command line interface. Yeah.
Oh,
what?
Okay.
Yeah, you can deploy the model in two places. I believe the CLI, but I know for sure in AKS, which is an Azure Kubernetes service. So that's you can either create a Docker image or you can deploy the model. So when you do these things like launch training, that's an experiment in the Azure Machine Learning. And then that also, you can evaluate the model, and you also do that with the Azure. You evaluate the experiment in the Azure Machine Learning. And then when you register the model, you're packaging that model up in the Azure Machine Learning, and then you can deploy it. And you can deploy it using DevOps. And then of course we have the piece where the data science team is they're actually checking in or their code, and then it kicks off this entire process. Okay. So the continuous deployment in MLOps is based on an Azure architecture recommendation, which you can click that link when Lev uploads it at some point. He probably already did, actually. So then we have what we call a CD pipeline, which is the continuous deployment pipeline. And so this little image here represents artifacts in DevOps. And what that does is it'll deploy a model in Dev, then a web service in the development environment it deploys it to that web service. So that would be like an AKS service. And the ML DevOps team will go and kind of look at it, make sure it's good. And oops, I'm sorry, I didn't mean to click anything. And then from there, it will go through testing. And this could be multiple steps. That's why it's like ... And then from there, you can approve this process automatically, or you can have a piece where a lot of clients or businesses, they'll want to actually make someone go and approve it. So that part will be a little bit manual, but the rest of it will be more of an automatic process. And then from there, it will deploy the model in production and send and deploy it to that web service. And that will go to the production team, or, the user also. Any questions?
No, very good.
Awesome. So I kind of put a general MLOps reference architecture. So I feel bad, Lev, I totally lied to you. You said, oh, did you add anything to your thing? And I added like 1 or 2 slides. So my apologies. So this is kind of a basic architecture, but we have, we have the Azure DevOps build pipeline, which, so there's 2 different things in the Azure pipelines. There's build and there's release pipelines. The build pipelines have, you can create them with the YAML files. And so I actually realized I can do a very small demo for you guys with the client I'm actually working with. The problem is the automated process isn't complete, but I could show you something. Because it's interesting because it actually doesn't it uses actually most of the stuff. But so anyway, so there's a trigger of some sort. So in the storage, you can have a trigger of like the it could be data driven, schedule driven, or metrics driven. So I'll give you an example from my client. They actually are, they trigger something when a specific model is registered by their data science team. And I actually use a logic app so in Azure Machine Learning, you can create something called an event subscription. And what that event subscription does is you can it'll say like, when this event happens, please kick off whatever. And it could be a logic app, which is what I used. It could also be, there was a couple other options in there. I forgot what the other ones were, but I'm specifically using a logic app, which isn't being shown in here. But so it kicks that off, and then from there, I actually start I grab the information of the model name and the model version. So in Azure Machine Learning, you actually have versioning of the models. So it's the same idea with versioning. Like if a model doesn't work or it's not the one you want, you can go back to a previous version. And you don't have to change like the name of it. You just have a new version. So it'll be like test model 1, that's version 1, and then test model 2, and so on and so forth. So when a new version of the model comes in, is the trigger that I have with one of my clients. However, sometimes they want to schedule it. It could be a weekly run, or it could be that also when there's data drift, you can actually create a trigger for that as well. I haven't personally done that yet, but I actually haven't done a schedule either. Mine's on the metrics driven. So anyway, I just kind of thought I'd give an actual concrete example, but it kicks off a build pipeline. This process in here is a little more, I'm so sorry, hold on. Okay, yeah, so if this, so when this trigger goes off in this, a more general flow, we have, Azure Machine Learning pipeline endpoint. That's what happens. They run an ML pipeline, and that register, oh, sorry, I'm thinking of my exact experience right now. So let me just go through this process first. But the Azure Machine Learning pipeline endpoint then kicks off an Azure Machine Learning retraining pipeline. So then it retrains the model. So it'll train, it'll evaluate, and it'll register the model. And then the AML model management will then, the operationalized model will kick off. That'll be the trigger. And so how that works is in DevOps, there's something called artifacts, and the artifact would then be triggered when the model is registered. So it will go here, and it'll say, all right, so now we're in the Azure machine learning and we need to do, this is like the staging and QA environment, which means that we're not quite in the, we're in the testing, the development, mainly the testing phase. So we package the model into image, we deploy it as a web service on, ACI, that's what I was thinking of. It's not CLI, my apologies. And I can't remember what that stands for off the top of my head, so my apologies. Oh, it's right here. Container instance, which can also be a Docker as well. And then it tests the web service, and it can then it would come to the Azure container instances, and then you can also monitor it. So this depends. It depends on the stage that it's on, but this is for staging and QA. And then then we have the manual release gate, or it could be automatic, and then it would go into the production phase, and it would deploy the model as a web service on AKS, and obviously test the web service, and then it would go to the Azure Kubernetes service. So, and then we would go to, all right, so now we're back to step one. So it's kind of a little confusing process, isn't it? Yeah.
Rachel, I want to say something. I think your presentation is extremely valuable for anybody who is working as a consultant, because when you need to draft your proposal for a client, what needs to be done, like you have all these diagrams already in place. It's kind of like a blueprint for the project, that maybe even making some financial estimates. I mean, this is great. This particular slide, I agree, it's kind of convoluted and confusing. Maybe it can be streamlined somehow, but
yeah,
but
still, I think this one maybe a little bit maybe needs a little,
but also it is complicated because it has all the moving parts.
Well, and not everybody uses the same. This is kind of a really general architecture as well, and it's probably for a very specific, it's kind of for specific use cases too. It depends on the client. So like I said, I'm actually doing 2 MLOps processes, and some of them use things like, they have one of them uses data factory and the other one doesn't. And one of them, most of their process, their data scientists and their operations people are completely separated. Like they're working in different repositories. So it's kind of, it's not like everything, like I would think that you'd want both the machine learning and the operations side of things to be in the same kind of like machine learning workspace, but they don't work like that. In fact, they have to run their own pipelines to register the model into the operations side of things in their environment. So it's a very complicated thing, because they're not doing it in the same way. Everybody's not going to do it the same way. So that's the other piece. But and one good thing to also, this is the last thing, this is my last slide, but this is one last thing I wanted to kind of point out, because I'm running into this issue myself, which is branching strategies for like MLOps. Mainly what you want to do is you want to have like a main branch, right? So we have this main branch here, and then we have a development branch. And you kind of want to keep them separated in the sense that when you create, and so you create your own branch to do your own development work, and then you put that, or you're fixing bugs, because that happens too, then you're putting that back into, and you're creating that pull request to merge it with the development branch. But then once you get something that's like a new feature that's done, and you're done with that branch, you can then merge it into the test branch, which then eventually you merge into the main branch. But it's also, it's a big thing. I feel like there's so many branches that I'm getting so confused sometimes, because like, you just want 2 main branches, and then you do your development, you put it in development, and then you move it over to main when it's like officially done. kind of thing. So that was something else I wanted to bring up. That's something, this is a very, like, take this very seriously if you have to use branches and stuff with DevOps. And of course, Git, DevOps uses Git. So it's, the same idea. But anyway, that's the last thing I'll say, but that's the, there's some resources here. If you guys want to look, there's some good training they have that Microsoft has, and best practices, data strategy, maturity assessment, and basic principles. So does anybody have any questions or comments?
Rachel, first of all, I want to say great thank you from everybody. I saw the slides, but I wasn't like spending too much time. But the presentation, how you like laid it off, really, really good. I'm so grateful that we have this cloud infrastructures, because when you think about the whole thing, how the hell you can do it all by yourself? Like there's no way.
No, you can't. No, you can't. It's definitely impossible. But it's also interesting because so in the past, from my experience, is that when I was with like Redapt or all the other companies I worked for before Microsoft, the operations side I never touched. I never did any deployments or anything like that. And I didn't realize how complicated it can get. And then they were like, oh, are you MLOps person? And I'm like, yeah. And then they started putting me in projects and I was going, no. I was like, oh, shoot. And I've had some growing pains since I started with Microsoft, because definitely don't know DevOps super well. I did not. I'm still learning a lot. There's a lot to it. It's very complicated. And there's just a lot of moving parts. And so I definitely have like a couple of clients that, are doing this, and that's literally that's all I'm doing right now. But I'm actually doing the operations side of the MLOps. I'm not even touching the ML stuff, because my clients, they're already done with all that. They've already got their machine learning models, like they're in place. They're just in the process of like making it more automated and improving upon certain things, like data drift. That's one that we haven't actually. So my client was doing, one of my clients is Geico, and they were actually moving, they were grabbing they had a pipeline and they have variables that go with that pipeline, and they were actually going and grabbing the version number, the model name and the version number. They were putting it into the variable group. Then they were running a pipeline. Then they would go and that pipeline would actually register a model in a different workspace. And then they had to go and grab the version number of the model that they just registered, which had a different version number because they're in different workspaces. And they were manually putting that into a different variable group, and then they were running a different pipeline. Nightmare. And I was like, oh my God, this is horrible. I was sitting there going, oh my gosh, you guys definitely need to automate some of this stuff, because they just, and so like this diagram right here, hold on, let me go back. This one, this is practically what I'm doing right now. And I've added this part, like the approval. We haven't gotten to that part just yet, but the approval piece is the part that we're adding as well, to say like, oh yeah, like, okay, so this person has to go and approve it because they have to manually approve it. And then it would finish off the pipeline of it, because it won't finish the pipeline without that approval. And then it'll deploy the model to an AKS service, Azure Kubernetes service. So.
Right. I want to ask others to say a few words, because we're over time and need to finish soon. Guys?
Yeah, this is Brett. Thank you, Rachel, for the presentation. Very informative. I just was curious, how many of your clients actually have like a dev and a prod machine learning workspace and kind of do their development in development and push models to production, or versus how many just kind of do development locally, and then when they're ready, kind of just go to the production workspace and deploy the
and do
model.
it there. Yeah. So both of my, so I only have 2 clients, and both of them have different workspaces actually. But with one of my other client, not Geico, the other one that I'm working with, they actually, we are creating a new environment for them, and we are only using one workspace for everything. So they're actually going to be not using multiple workspaces, one workspace per environment. Sorry, when I say, let me rephrase that. They created a whole subscription for us because we don't have enough access in the subscription that they're working in. But in our subscription, we have different resource groups, the different environments, but we'll only have one that has the workspace in it. And they'll do everything in there. So we're kind of redoing some stuff in that subscription, and then handing it off to them to do in the subscription that they already have.
I guess it sort of simplifies it a little bit if you only have to worry about what's in your production workspace.
Right. And so this will be, and I think that it's interesting because I used to think it would be better to have one workspace per environment, but then I realized I actually don't think that's true. I think it's better to have one, and you can do your everything in the same one, and it can speak to the different. I think it can speak to the different. Yeah. And so you can use it with different environments, but.
Right. You can put in a developmental data set in your production workspace just as easily as a real data set.
Yep. Yep. Good question, by the way.
Okay, so let us finish because we're seriously over time. Rachel, thank you. It was very good.
Thank you guys. Thanks so much, everybody.
Thank you so much. Yes, very informative.
Thank you. Have a great weekend. Thank you.
You too. Thank you so much.
Bye, guys.
Bye.
Bye.
Bye.